This is very important example. Here two matrices are given to us, A and B, and we need to prove that row space of A is equal to row space of B. For that, first we find the basis for row space of A, and then we find the basis for the row space of B. And then we need to check whether bases of row spaces of A and B are equal or not, right? Okay. So matrix A is given to us here. We need to first change this into row echelon form and then get the basis for the row space of A. So we need to get first 1 over here. How do I get 1 over here? By just dividing the first row with 2, right? So changing the row 1 and multiplying this row with 1 over 2. Then I get 1 over here? Yes. So 2 is multiplied with 1 by 2, we get 1. 4 is multiplied with 1 by 2, we get 2. 6 is multiplied with 1 by 2, we get 3. Writing the rest of the rows as it is. And then we need to make 0 over here and here, right? For that, what should we do? We need to change the row 2 first. Yes, and adding the elements of the row 2 to the elements of the row 1. But first row should be multiplied with minus 4 first. Right? Okay. 1 is multiplied with minus 4 and adding this to 4 we get 0. 2 is multiplied with minus 4 we get minus 8 and adding this to 4 we get minus 4. 3 is multiplied with minus 4 we get minus 12 and adding this to 10 we get minus 2. Now to make this to be as 0, for that we are going to change the row 3 and adding the elements of the row 3 to the row 1. But first row should be multiplied with, yes, minus 4 again. 1 is multiplied with minus 4, we get minus 4 and adding this to this 4 we get 0. 2 is multiplied with minus 4, we get minus 8 and this is added to this 8, we get 0. 3 is multiplied with minus 4, we get minus 12 and minus 12 is added to this 12, we get 0. Right? So we found this to be as our leading entry. Now for the second row, to make this to be our leading entry, for that we need to make this 1. How do I get 1 over here? Yes, so for that just multiplying the row 2 with minus 1 over 4 to get 1 over here. Writing the elements of the first row as it is, and the row operation for the row 2 is multiplying the row 2 with minus 1 over 4. So we get 0 is multiplied with minus 1 by 4, we get 0. Minus 4 is multiplied with minus 1 by 4, we get 1. Minus 2 is multiplied with minus 1 by 4, we get 1 by 2. Writing the third row as it is. Right? So required to make this as 0. For that, we are changing the row 1 and adding the elements of the row 1 to the elements of the row 2, but row 2 first is multiplied with, yes, minus 2. Multiplying 0 with minus 2, we get 0 and adding this to 1, we get 1. This is representing that this is the first leading entry for the first non-zero row. Just for your understanding, I am making the leading element with green colored pen. 1 is multiplied with minus 2, we get minus 2 and adding this to 2, we get 0. 1 by 2 is multiplied with minus 2, we get minus 1 and adding this to 3, we get 2. Writing the second row as it is. Writing the third row as it is. So now we find this to be our leading element or leading entry. Right? So the matrix is now in row echelon form. So therefore, the bases are, yes, from the row 1 we get 1, 0, 2. And from the row 2 we get 0, 1, 1 over 2. So this is the basis for row space of A. Please mark this as 1. Again, to get the basis for the row space of B, we need to change this matrix into the row echelon form first. 1 is already present over here, right? Just to make now this entry to be as 0. For that, we multiply row 1 with negative 2 and adding these elements to the row 2. So we are going to change the row 2 and adding the elements of the row 2 to the row 1, but row 1 should be first multiplied with negative 2. Writing the first row as it is. Okay. 1 is multiplied with minus 2, we get minus 2, and adding this to 2 we get 0. 2 is multiplied with minus 2, we get minus 4, and adding this to this 2 we get minus 2. 3 is multiplied with minus 2, we get minus 6, and adding this to 5 we get minus 1. Please remember, the row which you are going to change, that number should be present over here first, right? Okay, so this becomes our now leading element. To make this to be as 1, so for that, just dividing or multiplying the row 2 with minus 1 over 2, right? So changing the row 2 by multiplying the elements of the row 2 with minus 1 over 2. Writing the first row as it is. And now on applying the operation on the row 2, we get, yes, elements of the row 2 is multiplied with minus 1 by 2. Okay. 0 is multiplied with minus 1 by 2, we get 0. Minus 2 is multiplied with minus 1 by 2, we get 1. Minus 1 is multiplied with minus 1 by 2, we get 1 over 2, right? Okay, I get 1 over here now. Now to make this to be as 0. So for that, I need to change the row 1. So writing the row 2 as it is first. Alright. To make this 0, what should I do? Just multiply the row 2 with negative 2 and adding this to 1. So I'm going to change the row 1 and adding the elements of the row 1 to the row 2, but row 2 should be first multiplied with minus 2. Alright. 0 is multiplied with minus 2, we get 0, and adding this to 1, we get 1. There is no change. 1 is multiplied with minus 2, we get minus 2, and adding this to this 2, we get 0. 1 by 2 is multiplied with minus 2, we get minus 1, and adding this to 3, we get 2. So now we get this to be our leading entry. So we get the leading entries as 1 in both the non-zero rows. So this is your required row echelon form matrix, right? So now writing the basis for the row space of B, that is 1, 0, 2 from the first row and 0, 1, 1 by 2 from the second row. 1, 0, 2 from the first row and 0, 1, 1 by 2 from the second row. So these forms the basis for the row space of B. Now since, please mark this as 2. Now since from 1 and 2 what we get, let's check whether the bases are same or not. From 1, we are getting the basis for the row space of A to be as 1, 0, 2 and 0, 1, 1 by 2. And from 2, we are getting the basis for row space of B as 1, 0, 2 and 0, 1, 1 by 2, which are the same. Now since basis B1 is equal to the basis B2, therefore, row space of A and row space of B have same bases, right? Thus, row space of A is equal to row space of B. Hence proved. Thank you.